back at it again with another video, but this time we're going to have a tutorial video about solving problems involving properties of solutions and thermochemistry. So I'm gonna teach you how to solve molarity, boiling point elevation, and lastly calorimetry. There are several ways of expressing concentration, and molarity is just one of them. Molarity indicates the number of moles of solute per liter of solution. It is used to calculate the volume of solvent or the amount of solute. This is the formula used in molarity. M for molar concentration, N for moles of solute, and V for liters solution. Problem number 1. What is the molarity of 60 gram of sodium hydroxide in 250 milliliter of solution? So we're given everything that we need. First thing first, always write the given in the said problem so we can identify where we could put those values. As you can see, we don't have moles of solute. We need to convert grams to moles. In order to do that, we need to find the molar mass of sodium hydroxide. So here it is. Sodium is 22.99 gram, oxygen is 16 gram, hydrogen is 1.008 grams. So we only need to add up their atomic mass, and that is 22.99 grams plus 16 grams plus 1.008 grams is equal to 39.998 grams per mole. 60 grams of sodium hydroxide divided by 40 grams per mole is 1.5 moles. And then next, we also need to convert milliliters to the unit liters. In order to get liters, simply divide it by 1000. 1 liter is equal to 0.001 liters. Now that we have the appropriate values, we're going to divide it again. 1.5 moles divided by 0.25 liters is equal to 6 molarity. And that's the concentration of the problem number 1. Let's move on to another property, colligative properties. Boiling point elevation is one of it. It describes the phenomenon that the boiling point of a liquid will be higher when another compound is added, meaning that a solution has a higher boiling point than a pure solvent. This happens like whenever you add salt to water, the boiling point goes up. Remember, keyword is elevation. Problem number 2. 20 grams of sodium hydroxide was dissolved in 200 grams of water. Calculate the boiling point of the solution. We're gonna use the formula delta T for the change in boiling point temperature. Kb is the boiling point constant of water, that is 0.512 degrees Celsius per mole. M for molality of solution. I for Van 't Hoff factor, number of particles the substance will dissociate into, and it is used only in ionic compound. So we have the value for Kb. We need to get the molality and the I value. For molality, we need to convert the grams into moles, and we already get that one in the problem number 1. But we just have the different grams. 20 grams of sodium hydroxide divided by 40 grams of sodium hydroxide is 0.5. Next, for molality, we need to convert to kilogram. Simply divide it with 1000 again, since 1 gram is equal to 0.001 kilogram. 200 divided by 1000 is 0.2 kilogram. Now that we have the appropriate values, let's divide it again. 0.5 moles divided by 0.2 kilogram is equal to 2.5 molality. Next, since sodium hydroxide is an ionic compound, we have to get the Van Hoff factor. We have one sodium ion and we have hydroxyl ion. So the factor is 2. Now let's put the values in their places. So delta T is equal to 0.51 times 2.5 times 2 is equal to 2.55. Since the boiling point of pure water is 100 degrees Celsius, we have to add it to the 2.55 degrees Celsius. 100 degrees Celsius plus 2.55 degrees Celsius is equal to 102.55 degrees Celsius, and that's gonna give us the new boiling point of the solution. Let's move on to thermochemistry. Calorimetry is used to measure amounts of heat transfer to or from a substance. The formula we're gonna use in this is heat of metal is equal to negative heat of water. So recall that heat is equal to mass times specific heat capacity times delta T. Problem number 3. A 32.5 grams sample of copper at 45.8 degrees Celsius is placed into 105.3 grams of water at 15.4 degrees Celsius. What is the final temperature? And we're given the specific heat capacity of copper and water. So we're gonna identify each givens. So we're gonna use the formula heat of metal is equal to the negative heat of water. And we're gonna expand that, putting all the values that we found. So as you can see, the final temperature is only written as TF since we're gonna find that value in this problem. Then we're gonna multiply each side. 32.5 times 0.385 is equal to 12.5125. And on the other side, 105.3 times 4.184 is equal to negative 440.5752. Next, we're gonna divide each side to 12.5125 so that we can cancel it on one side. And then, negative 440.5752 divided by 12.5125 is negative 35.218. And then distribute negative 35.218 and we'll get this answer. As you can see, we have 2 TF. We're gonna combine like terms just like math. We're gonna move negative 35.218 TF to the other side and negative 45.8 to the other side. Even if you can't see it, there's a 1 in TF so that it will turn to 36.218. 542.24632 plus 45.8 is equal to 588.04632. We're going to divide both sides by 36.218 so that we can cancel it out, and then divide the rest value. 588.04632 divided by 36.218 is equal to 16.2 degrees Celsius, and that's our final temperature. That's it. Thank you for listening. Hope you like this video. Don't forget to subscribe on our YouTube channel. Advance Happy New Year, everyone!